Good morning, children. We are going to discuss about the next episode. That is episode number 14 on. See, we know we use different appliances. In that appliance, sometimes we want to increase current, and in some other case, we want to reduce current. For that purpose, we use resistors. How? By using resistors, we can supply different resistance to the circuit. For that, we want to know the combination of resistance. There are two different types of combination. Like this is a resistor of 1 ohm resistance, and this one is a resistor of 2 ohm, and suppose this one with a 3 ohm. Now we want to connect these resistors in series. When we connect resistance in series, see this resistance with a 1 ohm, its end is connected to second one. This is with a 1 ohm, this one is with a 2 ohm. Now see, this one end is connected to another one, and this be connected to this one, and this resistance is a 3 ohm. Now in this way, when we connect resistors, that is when we connect one resistor to the end of another one, and third one is connected to the end of second one, this type of connection we used to say as a series connection. Now we want to know how this current and resistance and potential related. For that, we want to know about Ohm's law that we discussed in the previous class. What is actually Ohm's law says? That means from Ohm's law, current through a conductor is directly proportional to potential difference between its ends. That is current proportional to potential difference, or potential difference is directly proportional to current through the conductor. From this we know this relation V proportional to I, or V by I is equal to a constant, and this constant we say as resistance. What it is called? Resistance. And this resistance for a conductor is same if the temperature remains same. And also we discussed about the factors which affecting resistance of a conductor. Which are they? Try to remember it. Which are the factors that affect the resistance of a conductor? Okay. Can you say? From that, one is length of the conductor. That means material which we used. One factor is length of the conductor, and second one, suppose this, see here two conductors, these are the resistors, that is this one is a nichrome wire and this one is another nichrome wire, both are of the same material, but see this one length is this much only, but what about the length of the second one? This one's length is this much more. From this you can understand length of these two wires are not the same, so that the resistance also not the same. So resistance of the conductor, that is resistor, depends on its length. And second one, it depends on second factor is what? Area of cross section. Otherwise, we can say cross sectional area or thickness of the conductor. Second factor that depends on length of the conductor. Second, area of cross section or cross sectional area. Otherwise, the thickness of the conductor or resistor. And third one is which is the factor that one is the material of the conductor. So these are the three factors that affects resistance of a resistor, otherwise a conductor. On length, this means if the length changes, resistance also changes. Second one, area cross section. It means when area cross section or thickness changes, resistance also changes. And third one is the material of the conductor. See, this wire is the nichrome. If we use instead of this nichrome wire, a copper wire of this length and this thickness, then its resistance will not be same as that of this one. Okay, so resistance changes with the material also, and also this resistance we got R proportional to L. This means when length increases, resistance also increases. When length increases, resistance also increases. And another one is R proportional to 1 by A. That means resistance inversely proportional to cross-sectional area. It means if the thickness increases, resistance also not increases, but here it decreases. That means when the area cross-section increases, resistance decreases. That is the meaning of this inversely proportional. And from this we got our new relation. What is the resistivity? You know what is actually resistivity? Okay, try to remember. What is the resistivity? From these two relations we know R proportional to L and also R proportional to 1 by A, or inversely by comparing this we get R proportional to L by A, or we can replace this proportionality with equal to sign, or that we want to give a constant that is rho L by A. This, what is the name of this rho? Can you say what is the name of this rho? Rho is the term. What it is? Resistivity. What it is? Resistivity. From this, and also we discuss about the unit of resistivity. Any of you try to say what is the unit of resistivity? What is the unit of resistivity? It is ohm meter. Its unit is ohm meter. Unit of resistivity is ohm meter. Actually, what is resistivity? Resistivity is also resistance. It is a material of unit length and unit area cross section. Unit length, a material with unit length and unit area cross section. Whatever is its resistance, that we used to say as resistivity. But you want to remember, resistivity for a material is same, even though if its length or thickness or anything changes, resistivity does not change if the temperature remains same. And also we discuss about metals with low resistivity and insulator with high resistivity. Okay, now see, these are the things you want to remember when we are going to discuss about series connection. What are the things you want to remember about Ohm's law that you know already? What is V proportional to I? It means current through a conductor is directly proportional to potential difference. From this we get V by I is equal to R. This term R is called resistance of the conductor. What is called resistance of the conductor, and factors affecting resistance of the conductor also we know. What is the unit of resistance actually? Unit of resistance is that also you know ohm. Which is the unit of ohm? Which symbol is used for this? Can you remember? Ohm symbol for this one is this. And resistance of a material depends on its length. Second one, area cross section. Third one, material. And fourth one also it depends on temperature. That does not discussed in our unit. And from this all we got the proportional to R proportional to L means if length increases, resistance increases. Otherwise, if length decreases, resistance decreases. If the length becomes double, resistance also becomes double. And R inversely proportional to cross-sectional area means if cross-sectional area or thickness increases, resistance decreases. That means if the thickness is doubled, then resistance becomes half. And now see here, R is equal to R proportional by combining these two we got R proportional to L by A, and from this R equal to rho L by A. The term rho is called resistivity and its unit is ohm meter. Okay, now we are going to discuss about this connection. Which connection? Series connection. See, series connection. How resistors connected in series connection? That means one resistor connected to the end of the another, and that one connected to the end of another. In this way, when we connect resistors, it is called there is a series connection. Another method is what is resistors can connected in parallel connection. See here a point X and here a point Y. These are the 2 points. Here the 3 resistors, that is this one, these 3 resistors, if we connected between these points, see, between the points X and Y, we connected 3 resistors. This type of connection is called parallel connection. This type of connection is called parallel connection. And now you got idea about what is the series connection and also what about parallel connection. Okay. Now we want to do one activity. In that, see. Two types of connections we discussed. Among that, first one is a series connection. Here, 3 resistors. We are taking 3 resistors. That is, first one is with 1 ohm. Second one is with 2 ohm. Third one is with 3 ohm. We want to know how much is the resultant resistance of these 3 or effective resistance of these 3. See, this one is with 1 ohm, 2 ohm, 3 ohm. 3 resistors are here. Now, current through this we can measure by using an ammeter. And see, we connected a 6-volt battery and plug key. Now this one is a 6 volt battery and this one is a plug key. This one is a ammeter. Now see, by closing this key we can measure current through the circuit. By closing this key we can measure current through this circuit and let we observe it maybe suppose 2 ampere current. Here it shows 2 ampere current. Where the ammeter is in this position. When the ammeter is in this position, current is shown let it be 2 ampere. Now the position of the ammeter be changing. Suppose here is the ammeter and when we close the key, we can measure current through this circuit, that means through all the resistors, and let it be 2 ampere. Now this ammeter we change to here. Now the position of the ammeter is in between 1 ohm and 2 ohm. Again we measure current by closing the key. Now also it shows 2 ampere. Now we again changes the position of ammeter from here to another position. Now the position of the ammeter is here. See, again the current shown in the ammeter is 2 ampere. That means if the current here is 2 ampere, here also 2 ampere. Here also it shows 2 ampere. This means current in the circuit is same. Current in the circuit is same everywhere. Current in the circuit is same everywhere. Even the position of the ammeter changes, then also there is no change current to the circuit. That means if we change the position of the ammeter in the circuit from here to this position and from here to here, then also there is no change in current. Then also there is no change in current in the circuit. That we must understand. That is when the resistors are connected. When the resistors are connected in series, there is no change in current in the circuit. See, we discussed about how to find effective resistance when the resistors are connected in series. Let us do one more activity. See, the first resistor, let it be R1, its resistance, and second resistor and its resistance R2, and third resistor of resistance R3. Instead of 1 ohm, 2 ohm, 3 ohm, we took it as R1, R2, R3. And one thing we got that current through all the resistors or through anywhere in the circuit is same, even though the position of the ammeter we change. Now here we connected ammeter and battery. Suppose it be 6 volt and the key. If we switch on this key, we can get a current to the ammeter. If we insert this plug in here, we get a current in the circuit. Now here we introduce on voltmeter. Now this voltmeter shows potential difference across these resistors. From this voltmeter we get potential difference across the resistors, and that would be VR. It shows an voltage of V. Now the current through this is I. We know from Ohm's law, V proportional to I, or V by I is equal to R, is the resistance. Now this R shows resistance of this R1, R2 and R3. That means effective resistance of these three resistors. This R shows what? Effective resistance of this R1, R2 and R3. Now to find current, we know that is from this V by I is equal to R. See, if you replace this R1, R2 and R3 and give another resistor of resistance, all of these together, or sum of these together, then also the current we get the same. Now to find potential difference across R1, we connecting an voltmeter here. Here when we connect voltmeter, it shows a potential of V1. Here it shows a potential of how much? V1. From this we know what is V1. How we can get a V1 is the potential difference across this R1. Similarly, potential difference across R2. Here, if we connect a alternator, here, we get a potential difference here as V2. And if we connect it here, then we see between the ends of the R3. If the alternator is connected here, we get here as potential difference V3. Now, from this, V1 is the potential difference across R1. Similarly, V2 is the potential difference across R2, and V3 is the potential difference across R3. By adding these V1, V2 and V3, we get V is equal to V1 plus V2 plus V3. That is whatever is the potential shown here, whatever is the potential is in this alternator, the same is equal to V1, V2 and V3. Now see, from this relation V is equal to, we know, IR, or that means V by I is equal to R, or V is equal to IR. If we replace this relation, that means instead of V, if we give IR, see, V by I is equal to R, or V is equal to I into R. So instead of this V, we can give IR, and V1 is equal to, that means the potential difference across R1 is equal to, we know that the current through all the resistors here same. So we can take it as IR1. In the same manner, potential difference V2, current is same, resistance R, so I into R2. And here, that means V3. That means in this relation V3 is equal to what it will be? If V1 is I into R1, V2 is equal to I into R2, then V3 is I into R3. See, I R is equal to I into R1 plus I into R2 plus I into R3. these all we can take I common. Then what will come? R1 plus that means we can cancel I from both sides. Then we get R is equal to but R1 plus R2 plus R3. That is total resistance in the circuit. Total resistance in the circuit R is equal to R1 plus R2 plus R3, which is greater than any of the resistance in the circuit. That means here if we use 1 ohm, here it is 2 ohm, here it is 3 ohm, then the total resistance R is equal to, that means 1 plus 2 plus 3, that is 6 ohm. See, this total resistance is more than any one of these resistance. That means more than 1, more than 2, more than 3 also. That means when the resistors connected in series, the total resistance or the effective resistance in that circuit is more than any of the individual resistors. Any of the individual resistors. That means here total resistance we got as R is equal to 1 plus 2 plus 3, that is 6 ohm, or otherwise we can use this relation to calculate R is equal to R1 plus R2 plus R3 when the resistors are connected, in series. Okay. So in order to increase resistance in the circuit, we want connect resistors in series. Now with this we want to do some problems given here. First one is an electric lamp whose resistance is 20 ohm. Here it is given. This resistance is 20 ohm. And a conductor of 4 ohm resistance are connected. Here a conductor of 4 ohm resistance are connected. Calculate total resistance in the circuit. That we say here in the circuit there is a 6-volt battery, then an ammeter to measure current, and a plug-in. Whenever is required we can switch on or off the circuit. These are the things here given in the figure. See the question once again. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm are connected to a 6-volt battery. Calculate a total resistance of the circuit. What do you want to calculate? A total resistance. First of all, you want to calculate the total resistance, that is R. We know when the resistors are connected in series, effective resistance or total resistance is given by R is equal to R1 plus R2 plus R3 etc. Here, how many resistors? One is 4 ohm and one of 20 ohm. Now, first we can take as R1 is equal to 4 ohm. And second one is that is R2 is equal to 20 ohm. Now you know how to calculate total resistance. That is R is equal to, that means R1 is 4 ohm and R2 is 20 ohm. Then 4 plus 20, how much it will be? 24 ohm. This is the total resistance now in the circuit. Total resistance now in the circuit when the switch on, the bulb will blow. At the same time, total resistance to the current in the circuit, total resistance to the current in the circuit is given by 24 ohm. That we got. How much it will be? 24 ohm. This is the answer for first question. Now again, we can go to the next one. That is B. The current through the circuit. Now we want to find out the current through the circuit. Current. The letter I. You know, current I is equal to potential difference. That means V by total resistance R. So I is equal to V by R. Here V we know that is potential difference. We have given us 6 volt. That this one. Potential difference of the battery. And next one is total resistance. We calculated it as 24 ohm. Now in this relation, then this I is equal to V by R. If we put this values, that means I equal to V, that is 6 by R, 24. 6 by 24 is equal to, we know here 1 times 6, here 4 times. That means 1 by 4. 1 by 4 is equal to, how much it will be? 0.25. Which is the unit of current? Unit of current, actual unit is potential volt by resistance. That means its actual unit is this volt and this one is ampere. Volt by ampere. Volt by ampere is actually what is volt by resistance unit is ohm. Volt by, that means ohm. Volt by ohm it is called ampere. That is ampere. How much it will be? 0.25 ampere. Now this is the answer for question B. Now that is current through the circuit is now how much through the circuit current we know what is going from positive to negative, and current here also 0.25 ampere, through this also 0.25 ampere, through this key when closed also 0.25 ampere. That is throughout current remains the same. There is no change in current in the circuit. Throughout the current is same. Now the question C. The potential difference across the electric lamp and conductor. We want to find out the potential difference across this lamp and also this conductor. See, potential difference across this lamp, we know what is V is equal to potential difference across the lamp. We know current through all this all is same. Here let the potential difference here be V1. Then potential difference V1 is equal to IR1. That is potential difference across the lamp. Potential difference across the lamp V1 is equal to I into R1. That is equal to I 0.25 into R1. R1 is how much? That is 20 ohm. That is equal to how much it will be? That is 25 into 50. Then on 0. Now we want to give 2 decimal place. Then what will come here? That is it will be equal to 5. What is the unit of potential difference? Volt. So potential difference across the lamp is 5 volt. Now what we want to find out again? Potential difference across the conductor. That means that here the potential difference we can take as V2. potential difference across the conductor. Potential difference across the conductor V2 is equal to, that is I current same, let that resistance is R2, that is I R2, that is 0.25 into resistance here 4, that means here resistance is given as a 4. So this, when 25 into 4 we get as a 100, 2 decimal place, then what will come? It is 1 odd. It is 1 odd. So the total potential C 5 plus 1 6 volt will come. If we replace this 4 ohm and 20 ohm with another single resistor of how much 24 ohm, then also the current will be the same, potential also here will be same. Now the 3 questions answer we got. Which are the questions here given? First we got the answer for total resistance. Second we got what is current, and third one potential difference across electric lamp. Potential difference across electric lamp, here we take the resistance as R1, and potential difference here we take taken as V1. So V1 is equal to IR1, current is same, so this will be. And next potential difference across the conductor, that is V2, I into R2, this we got as 1 volt. See, these are the example here given. Now 2 questions given here also. The first question given here, draw a schematic diagram of a circuit consisting of a battery of 3 2-volt cells. 3 2-volt cells. Then 5 ohm resistor, 8 ohm resistor and 12 ohm resistor and a plug key are connected in series. What are the things given? Draw a schematic diagram of a circuit consisting of a battery of 3 cells, 2 volt each, 5 ohm resistor, 8 ohm resistor, we want to include 5 ohm, 8 ohm and also 12 ohm. 12 ohm resistor and plug key are connected in series, and plug key. These are all connected in series. Now, how we will connect this all? That means we want to draw the schematic diagram. So, first of all, we can draw 5 ohm. We know to connect in series, what we want to do? We want to connect to the end of one to the other. See, the first one it said we connected to the second, that is 8 ohm. Then to the end this end we connected 12 ohm. And again see, we connected 5 ohm, 8 ohm, 12 ohm. That are in series. Now we want to connect what is 3 2-volt batteries. 3 2-volt cells. When these are connected, it will become a battery. So we can connect these 3. Now first one, second one and third one. Now these 3, that means 6 ohm. We know current flows from positive, that means this long line is the positive to negative. And again we want to connect there is plug key. If here we put this is closed circle. Now this is the schematic diagram that the question asked to you draw. Which are the things you want to remember? 3 2-volt cells. Here 3, 1, 2, 3. Total 6 ohm. And 5 ohm, 8 ohm, 12 ohm. These are all connected. Now, see, then plug the key also. Now, this question answer is over. Now, another one question is given there. The next question, redraw the circuit question 1. Putting in an ammeter to measure the current through the resistors and an voltmeter to the potential difference across 12 ohm resistor, what would be the readings in the ammeter and the voltmeter? See, this diagram again you want to redraw, but in that you want to include an ammeter and also voltmeter across 12 volt resistor. Once again the question, redraw the circuit of question 1. Putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and the voltmeter? See, these are the things you want to redraw. 3 2-volt cells, then 5 ohm, 8 ohm and also 12 ohm resistors. Then you want to include an ammeter and also voltmeter and also plug key. These are the things you want to include in the circuit. See, these are, first of all, this we can take as a 5 ohm, then 8 ohm, then 12 ohm. Now to these 3 cells, 2 volt. And ammeter you can connect anywhere. Here you connect ammeter. Now here plug the key. These are all series. Now what are the things you included? 3 2-volt cell. 1 2 3, that is total 6 ohm. Then 5 ohm, 8 ohm, 12 ohm. 5 8 12, that are in series. Then ammeter, that also included here. Then plug key, that also here. Now one more thing you want to, it is voltmeter across 12 ohm. Here the potential you want to find out, voltmeter across 12 ohm resistor, that you want to find out. Okay, first of all you want to find out the current, then potential difference across this one. See, to find the current, we want to find out first total resistance in the circuit. Total resistance in the circuit, that is R is equal to R1 plus R2 plus R3. Because here 3 resistors are given. One is 5 ohm, 8 ohm and 12 ohm. Here first we can take as R1 as 5 ohm, R2 as 8 ohm, R3 12 ohm. Now if we put these values in this equation, what we get, R is equal to R1, that is 5 ohm plus R2, 8 ohm plus R3, 12 ohm. Now how much it will be? 5, 12 plus 8, 20 plus 5, 25 ohm. This is the total resistance in the circuit. We know when the resistors are connected in series, current through this 5 ohm, current through this 8 ohm, current through this 12 ohm, that are equal. So same current is flowing through this all. So we are going to find out the current. We know current I is equal to potential difference by resistance, that is V by R. Here V is 6 and R is 25. Now we can divide this 6 with 25. 6 by 25. That means from 6 we cannot take 25. So we put decimal point. Now it becomes 60. How many times in 60 25? 2 times that will come as 50. Now 0 1. Again we put one more 0. Now it becomes 100. In 100 it is 25. How many times it will be 4? That means 100. So current through the circuit I is equal to 0.24 ampere. 0.24 ampere is the current through the circuit. Now, question is to find potential difference across this 12 ohm. So potential difference across 12 ohm, that we can take as V3. V3 is equal to, that means current is same, that means I into here resistance we can take as R3. That is equal to I 0.24 is given, 24 into resistance 12. How much it will be? That means 0.24 into 12. 8, 4, 4, 2. That means here 2 decimal place, that is equal to 2.88 volt. This is the potential difference across. This is the potential difference across the potential difference across the 12 ohm resistor. In the same manner, can you find out the potential difference across this 8 ohm? That is V2. It is your duty to find the potential difference across this 8 ohm. Let it be V2. How we find out? We know V2 is equal to, which is the equation we can here given. If V3 here, potential difference here we take as V3, that is I into R3. Similarly here, we can, second one we can take as V2. V2 is equal to I into R2, that is equal to I, that is 0.24 into R2, that is 8. How much it will be? That means 0.24 into 8. 8 times 4, 32, minus 3, 1 point, that is equal to 1.924. Then, in the same manner, if you find out what is difference across this 5 ohm, that is V1 is equal to I into R1, we can get a potential difference across this one. Because current through this all remains the same. Current through this all remains the same. Now, the two questions which given here we solved. Now we can go to next. Okay, with this all we can wind up today's class. and we can discuss about next topic about parallel connection in the coming class. Okay, thanks.